Hi guys, so today we're going to go over sum and difference of cubes, which are two terms that happen to be perfect cubes, meaning you can multiply a number by itself 3 times and get whatever the first term is, and also multiply something by itself 3 times and also get the second term. Unlike a difference of squares, there is a formula for the sum and the difference of cubes. So notice for the sum and the difference of cubes, the factored form is pretty much the same, like they have the same terms, a, b, a squared, ab, b squared. The only difference is in white, and to remember that, you just need to remember SOAP, which just means same, opposite, always, positive. So what does that mean? Well, for the sum, we'll have plus, so if I look at the factored form, first one's the same, next one is the opposite, meaning minus, and then third will always be positive. If I look at the difference of cubes, meaning subtracting the two perfect cubes, it will be the same, meaning a minus sign as well. Next will be opposite, plus, and then the last one is always positive. So that's just one method you can use to remember the formula itself. Now notice in number one, we do have a difference of cubes. So a to the third minus b to the third. Keep in mind, there's no GCF, so I already checked. We're going to start by finding out what a and b are, because once I find out what a and b are, I can just write it in its factored form. So x to the third power is my first term, which is a to the third power. So I'm just going to start off by writing a to the third power equals x to the third power. I need to know what a is, so you can either find something that multiplies by itself 3 times to give you x to the third power, or you can do it algebraically. The way to get rid of a third power is to give it a 1/3 power. Whatever you do to one side, you do to the other. So why is that? Well, remember when we have x squared, the way to get rid of a square is a square root. A square root is nothing more than a power of 1/2. So if I wanted to get rid of a cube, I would give it a cube root. And a cube root is nothing more than a power of 1/3. Just like a fourth root is nothing more than a power of 1/4, fifth root is 1/5, so on and so forth. From here, remember if you have a power to a power, you multiply. 3 times 1/3 is just 1, so that's a to the first power, equals x 3 to the 1/3 power. Power to a power, I multiply. 3 times 1/3 is just 1, so I know that a is x. Remember not to take the minus sign because there is a formula for sum and one for difference, so I don't need to take the minus sign with it for b to the third power. I know it's going to be the second term 125. So again, you can find a number that multiplies by itself 3 times to give you 125. Or you can do it algebraically, meaning get rid of the exponent of 3 by giving it a power of 1/3. As long as whatever you do to one side, again, you do to the other. So 3 times 1/3 power to a power just gives me b to the first power. So 125 to the 1/3 power, if you're going to type this into the calculator, make sure, so 125 to the whatever your exponent key is, make sure that you put the exponent in parentheses. So 1 divided by 3. Otherwise, it will just raise 125 to the first power and then divide that answer by 3. So if you type in 125th to the 1/3 power, you should get 5, which does make sense because checking it 5 times 5 times 5, a number multiplied by itself 3 times, will give me 125. So once I have what a and b are, that's all I need to write its factored form. So again, we're taking the difference formula, which is the second one. So a minus b would give me x minus 5. And then I have a squared, which is x squared, plus a times b. So if I multiply 5 times x, I'll just get 5x. Remember to always put the coefficient first. And then plus b squared. So if I take b and square that, it'll give me plus 25. So that's its factored form. Number 2 is similar, but if you look at it, the two terms are even numbers, which means I can factor 2 out first. And if I factor 2 out of 2x to the third power, I'm left with x to the third power. If I factor or divide 686 by 2, I'll get plus 343. So just like in the other tutorials, when I have my GCF, I'm just going to underline it so I remember to actually bring it down with my final answer. In the parentheses is what I'll be factoring. So notice I have a sum of cubes where a to the third power is x to the third power. So if I just do the same thing I did last time to find out what a is, I'll give it a power of 1 over 3, keep it balanced on both sides, and that'll give me a equals x. Sum, remember there's already a sum formula, so I don't need to worry about the operation itself. The second term is b to the third power. B to the third power equals 343. Again, you can either find a number that multiplies by itself 3 times to give you 343, or you can give it a power of 1 over 3 to get rid of that 3 and make sure you balance it. So 3 times 1 over 3 would just give you b equals 343 to the 1/3 power. Make sure again you put the exponent in parentheses, and that should give you 7. And then you can always check it by multiplying 7 by itself 3 times. And then once we're done with a and b, we can just write it in its factored form using, in this case, the sum formula for the sum of cubes. So a plus b would give me x plus 7, and then a squared would be x squared minus a times b, so minus 7 times x, and then plus b squared. So if I square 7, which is b, I'll get 49. I'm almost done. Just remember to bring down your GCF and you have your factored form. All right, guys, I hope this